Alright, let's do a little wrap up on electrical safety. So why bother making electricity that goes one way and then the other and an alternating current? What's wrong with it just going one way? We covered this in a previous topic. We can transform it, we can change it to whatever voltage we want. It also allows it to be more distributed more efficiently. And also too, when we're actually making it, it's just more convenient instead of having a big long wire that you pull through. If you have huge coils of wire, and that way you're getting more densely packed wire and you're turning it inside of a giant magnet, it's just easier to make it that way. So AC is also the easiest kind of electricity to make in large amounts. If AC goes back and forwards all the time, how can it get anywhere? We have to understand current. So think of current as water in a pipe. Yes. So if I have a pipe filled with water and I put one drop in, one drop has to come out. Wires are just like water in a pipe, except this time my wire is filled with electrons. So when one electron goes in, one electron has to come out. And we're talking about 200 million electrons in just 1 centimeter long wire. So that's the way we should think about it. It's not that the electron from the power supply factory has to make it all the way to my house. No, there's already wires filled with electrons and they're all just being pushed or pulled in the same direction. So when someone gets electrocuted, what kills them? Is it the current or the voltage? Current, your body has a lot of resistance and takes a lot of energy for electricity to go through it. So as this electricity goes through your body, it heats the body up, literally cooking it. People who are electrocuted often have burn marks on their body from this heating up. Most often, though, that you're going to die because your muscles, including your heart, the most important muscle, works on electrical impulses, and when you get electrocuted or come into contact with electricity, it can really screw up the rhythm of your heart, and it can be difficult to get it back into a routine. If you are ever receive an electric shock, and you might say, whoa, 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 and think that everything's going to be okay, I urge you, if you remember this in your future, go to the hospital, tell them what happened. They would hook you up to an EKG and they would listen to your heart for quite a while to make sure that the rhythm is okay. I had somebody I used to work for this happened to, and he got into a lot of health problems because he did not go right away. He went the next day when he was really starting to not feel well, and he could quite easily have died from what happened to him. High voltages can be more dangerous than low ones because it's voltage that makes things jump across. So if I have this is my finger, yes, it's my hand. If I get close to something that is live, electrical charge, if there's a very high V, there's more of a chance that it's going to spark and jump to me. So voltage can be a big problem too. It also usually, when V goes up, I goes up. So high voltages can be very dangerous. Some things have a high V and a small I, like the Van der Graaf generator. If we were in class right now, I'd pop it out and have you try it. But Yeah, it's a neat little toy, but in this case, I is very small, so you're safe. Um, why do we not call wires the plugs on the two little prongs on a plug plus and minus, like on a battery? Um, why don't we call why do we call them live and neutral? Well, it's because the current is going back and forth. So to call them plus and minus would be completely incorrect, because half the time, because the current's going back and forth, back and forth, back and forth, half the time the current is going in a plus direction through one prong, and then that same prong, the other half of the time, it's going in the other direction. So it would be technically incorrect to call one of the plugs plus and one of the plugs minus when both of them are plus and minus at different times, and it switches 50 or 60 times each second depending on where you live. What's stopping us from making a battery that's as good as AC? It's just takes a lot of there's a lot of resistance in these chemical reactions in a battery are producing a voltage and producing current. The current has to fight its way around a circuit and through the battery itself. That takes energy, and then once the chemicals have reacted, the battery can no longer make voltage. It's run out. Now, if it's rechargeable, you plug it back in, and by plugging it back in, you're forcing the chemical reaction. You're forcing the chemical reaction to go this way to remake a bunch of A so that you can turn it back into B later on. If you're just a normal old-fashioned battery, then yeah, it's just dead. Yes. So yeah, it's just batteries just are not ever going to be as good as an AC current. Yeah. So why do some plugs have 3 pins? Yeah, what's the third one for? The third one is a contact to the earth. It's a direct contact to the ground. The ground is what we call a sink, or it's a source for electrons. Sink meaning it's a place where we can stick them, and electrons don't like to be near each other because they all have a negative charge. They want to get away from each other, and so they want to get to the ground because the ground is really big, and as soon as they get to the ground they can spread out. So the third pin is to the earth. It's usually larger, it's usually thicker, it's a safety system designed to avoid electrocution. It's connected to metal on your electrical device, so especially any metal that you might be touching when the thing is plugged in, and so that if something happens, the hope is that this third prong, which is attached to metal in the device you're using, if there's something goes wrong, the electricity will flow through those metal bits that usually isn't supposed to touch and directly to the ground and not go through you. Now, if there's two choices, through you or through this third prong to the ground, it's going to choose the third prong because the third prong has a smaller R. More current, if there's two paths, yes, for current to travel, more current will travel through the one with the smaller resistance. It's just easier. It's like a traffic. There's two ways. If there's two paths, two roads to drive somewhere, and they're both the same distance, you're going to take the one that has the less amount of traffic, the smaller resistor, or the smaller number of traffic lights, let's say. That's the one you're going to take because everything will back up there. So that's this third pin is a safety feature, hoping that current will flow through that and not for you. And that's our little look at electricity wrap up.